When I talk to people about Oracle performance tuning, I get a lot of interesting comments. Many seem to think that Oracle performance tuning is some sort of black magic, based more on sorcery than on engineering principles. Others simply regard their Oracle database as a black box and don't know much about what happens when Oracle processes their SQL statement or why things run fast or slow. Mostly what I find, though, is a lack of understanding of how Oracle works and what drives Oracle performance. And this is unfortunate, because without an understanding of how this major system component works and behaves, it is much harder to design and deliver a system that performs adequately for its end users. If you are not a pilot, sitting in the cockpit of an airplane can be a little bit overwhelming. There are all kinds of instruments, gauges, and controls that you have no idea what function they perform or what information they are providing you. But to the trained eye, these instruments provide critical information about what is happening and what the pilot should do to control the aircraft. In a lot of ways, this is very similar to Oracle. Oracle is a highly instrumented system. It makes a wealth of data available to us about what is happening inside of our Oracle database server, how a SQL statement is going to perform, and what is causing the statement to perform slowly. What we have to do is learn to read and understand this information that Oracle is giving to us. When we do this, we can take a very analytical approach to performance tuning and have a good idea about the corrective action we should take when we do encounter a performance problem. The question always comes up, who should be responsible for database performance tuning? In many organizations, this has traditionally been viewed as a DBA responsibility. It is my belief, though, that application developers should be skilled in database performance tuning and indeed should take the lead in performance tuning of their applications and the data access layer. There are several reasons for this. First, the application team knows the data in the database very well. This includes how the tables are related, what data they contain, and how the data is distributed throughout the system. Second, they understand what the application is trying to do and how data flows through the system in order to accomplish each function. And finally, the application team is familiar with what the user needs and expectations are for each function, so they are in a better position to evaluate alternative approaches to performing a task and the associated performance trade-offs. Now, it is possible for a DBA to be familiar with all of these items as well, but it is usually the application team who has the best perspective on each one of these elements. And in order to conduct really effective performance tuning, you need to understand not just SQL statements and tables, but what the application is doing, how it is trying to do it, and how all of the major components interact together. The second reason why you as an application developer should be well versed in database performance tuning is that you want to integrate the ideas of performance tuning and testing into your development process and not wait to complete these tasks until the end of your project. By keeping performance in mind from the start of your project, you'll be able to design your application to avoid known performance pitfalls. You'll also understand how to examine the performance of each of your components individually, so you can get a measure of their performance early on in the project. And designing performance in from the start allows the application team to take end-to-end responsibility for the experience that their application provides. What is needed then is to give application developers the training and tools that they need to create well-performing responsive applications. And that's what this course is all about. To do this, the course is divided into 4 major sections. The first section will familiarize you with the basics of Oracle architecture and what you need to understand from a performance perspective. There's a lot of material already written on the subject of Oracle architecture, and much of this material dives right into the fine details right away. Our aim, though, will be to teach you the most important parts for what you need to know in order to performance tune your application. We'll also talk about performance metrics and how we measure performance. Measuring performance goes past just looking at how long a SQL statement took to run, so we'll discuss the metrics you should be looking at and what they mean in this section. Finally, we'll talk about connecting to Oracle. Connecting to Oracle is something that we do all the time but seldom think about. So we'll talk about some of the best practices for our applications to use when we do connect to Oracle. Next, we'll move into a discussion around tuning individual SQL statements. The first topic will be on the use of bind variables in your SQL statements and why this is so important with an Oracle database. We'll then move into how to generate, read, and analyze execution plans for your SQL statements. An execution plan is how Oracle tells you how it is going to execute your SQL statement, so knowing how to read and interpret these results is critical for when you need to troubleshoot a slow SQL statement. The next section of the course will deal with indexing. Having a properly indexed database is probably the most important factor in the overall performance of your data access layer, so we'll go through indexing in depth. This will cover everything from the different types of indexes, how Oracle evaluates if it can use an index, to some more advanced capabilities that Oracle provides to address some of the special situations that may come up. Finally, we'll talk about some indexing strategies for your application and go through some of the common reasons why Oracle may not be using an index that you've created. In the last section of the course, we'll talk about how you can monitor what Oracle is doing in real time. This is invaluable because you can see what statements are performing poorly while your application is running, and you'll know exactly where to target your tuning efforts.